Dear students, I've come with a new module, Computation of Standard Deviation. This is an important module because we usually use this in social science studies. So if you see the introduction, this concept is introduced by Carl Pearson in 1893. Now we are in 2021. Now also we are learning this and we are using this for comparing the variation among distributions. So that is the importance of this module. Mostly used for studying the variation or the dispersion. It satisfies most of the good properties of a good measure of dispersion. And this is also known as root mean square deviation because standard deviation is the root of the means of the squared deviations from the arithmetic mean. Arithmetic mean is the average we are using and we are computing the standard deviation using the square root of the deviations. That is why it's known as root mean square deviation. When we do the problems, it will be more clear. So it's denoted by the Greek letter sigma. An absolute measure of dispersion is the variability of a distribution. So standard deviation is the absolute measure of dispersion. Then a small value of absolute distribution, that meaning a small variation of standard deviation or a computed value, if the value is small, then we can say that there is high uniformity among the observations. But if there is large deviation, that meaning there is high degree of variation among the variables or the distributions. Now, two or more comparable series with identical or nearly identical means can be compared using this measure, that is the standard deviation, and useful in judging the representativeness of the mean. If you know that two batsmen, they are scoring high. So if you want to see that who is a best performer or who is a satisfactory performer, so that is how we are calculating using standard deviation for the comparison. Now, next we have to see that what are the differences between mean deviation and standard deviation. 2 points are there. We have seen that mean deviation, signs are ignored in computing the mean deviation. So that is the main limitation of mean deviation. Whereas standard deviation, signs are considered. If it's plus or minus, it will be considered in the computation. Now, computation, whether we can compute using mean deviation or median. Mean deviation can be computed either using mean or median as the average. Whereas standard deviation, we can compute only using mean. So these are the two differences between mean deviation and standard deviation. Now, computation of standard deviation, we are dividing into individual observations, discrete series and continuous series. So individual observations, two methods are there, taking deviations from actual mean and taking deviations from assumed mean. Taking deviations from actual mean and assumed mean, it is to simplify the calculations. So whichever you are finding comfortable, you can use the method. Both the methods I will explain. So formula is sigma is equal to root of sigma x squared divided by n. So x is equal to small x, that is equal to capital X minus x bar. You know that x bar is the mean of the distribution and n is the number of observations. Now first problem we will take using actual mean. So calculate standard deviation for the following observations. Values of x 10, 20, 30, 40 and 50. The total value is 150. First we have to calculate the mean of the distribution. Mean is equal to sigma x divided by n. Sigma x, now we have seen that it's 150 and number of observations 5. So 150 divided by 5, you will get 30. Now standard deviation, you will use the equation root sigma x squared divided by n. So you have to take the deviations. Small x is equal to x minus 30. 30 is the computed mean. So minus 20, minus 10, 0, 10 and 20. The deviation will be always 0. Total will be always 0 when you are taking deviations from the actual mean. So x squared values you have to take 400, 100, 0, 100, 400. Total you are getting 1000. So when you substitute the values, standard deviation is equal to root 1000 divided by 5, that is equal to 14.142. Now, if you are taking deviations from assumed mean, earlier problem we got a whole number as the mean, but if you are getting mean as in fractions, then the computation is very difficult. Taking deviations, taking the square root, all this will be difficult. So we are taking the simple method, that is you can take a value as assumed mean and you can do the computation. Then the equation also will be different. That is standard deviation is equal to sigma d squared divided by n minus sigma d by n the whole squared. And we have to take the square root also. So d is the deviation from assumed mean. So a is the assumed mean value. Now we will see that how we will do the computation for the same problem. 5, 15, 25, 35, 45, 55 and 65. So we have to take the deviations x minus 10. 10 we are assuming as the assumed mean. So minus 5, 5, 15, 25, 35, 45, 55. Total is 175. Now d square values, that is 25, 25, 225, 625, 1225, 2025 and 3025, and total we are getting 7175. Now we have to see the values. Standard deviation, sigma d square divided by n minus sigma d by n the whole square, and we have to take the square root. That is, substituting the values, 7175 divided by 7 minus 175 divided by 7 squared, and taking the square root. So the value is 20. Now, discrete series, again the idea is to simplify the computations. So we have three methods for that. One is taking deviations from actual mean, taking deviations from assumed mean, and step deviation method. Step deviation method computation is very simple. So I always advise the students to use the step deviation method. Calculations can be simplified. So formula while taking deviations from actual mean, square root of sigma fx squared by n. X is equal to same. X, capital X is the x values minus x bar is the actual mean, and n is the number of observations. So compute standard deviation using actual mean method. X values are there 10, 15, 20, 25 and 30. So n is equal to the total frequency. So f values 2, 4, 8, 5 and 1. Now we have to compute the mean value. Mean value, you know that sigma fx divided by n. So multiply the values of x and frequency values, you will get the total as 395. So n is the total frequency, that is 20. So you will get the mean value as 19.75. Now we have to compute the standard deviation. Standard deviation is taking the deviations from the actual mean value. So 19.75 we have to take the deviation. So that is, when we have the equation sigma x squared divided by n and take the square root. That meaning values of x are there, values of f are there, and small x value is capital X, that is the observation values 10, 15, 20, 25 and 30. Taking the deviations from 19.75. So you will get the values minus 9.75, minus 4.75, 0.25, 5.25 and 10.25. Then take the x squared values and fx squared values. So we can substitute the value. Fx squared value is 523.724 divided by 20. So you are getting 5.1174. Now we have to take the assume mean method, because if the actual mean is in fraction, the previous problem we got 19.75. So the computation was difficult. Now we can take an assume mean. So d is equal to x minus a, where a is the assume mean and n is the total frequency. So the equation will change, sigma d squared by n minus sigma d by n whole squared, and take the square root. So when we do the problem, we are taking assume mean as 20. 19.75. So we can take in around value. So that is roundabout value or the complete value, that is 20 we are taking. So deviations d we are taking from x minus 20. Then fd values, d square values, fd square values. Now we have to substitute the values in the equation, that is 525 divided by 20 minus 5 divided by 20 squared, and to take the square root. So you will get 5.1174. Now the step deviation method, I told you this will simplify the computations, and standard deviation is equal to, the only difference is that you have to multiply with a common factor. So I, you can see in this equation, I is the common factor. It's the discrete series. Difference between the values is 10 or 5. That will be the common factor. So d is equal to, when we calculate the deviations, values of x minus assume mean divided by the common factor. So that you have to remember. So one problem, compute standard deviation for the following data using step deviation method. Length of screws in centimeters, that is 4.5, 14.5, 24.5, 34.5, 44.5, 54.5 and 64.5. See, the difference is 10 here. So that is 10 is the common factor. Number of screws 1, 5, 12, 22, 17, 9 and 4. Now we have to calculate the mean and the standard deviation. So the table is giving the complete explanation. Values are there, f values are there, x, we are taking the assumed mean as 34.5 and we are taking with the common factor, that is divided by 10. That is will be the d values. So fd values are there, d square values are there, fd square values are there. Now we'll substitute the values in the equation. Root of 130 divided by 70. 70 is the frequency total, minus FD values are 22. 22 divided by 70 squared, and take the square root and multiply with the common factor. So you will get 13.26 centimeters. Now for continuous series, you have to remember that we are using the step deviation method itself, but here I will be the class interval. Discrete series, it's the common factor. I told you the difference between the values, x values. So either it can be 5, 10, 20, whatever the value. Whereas class interval or continuous series meaning it is the class interval 10 to 20. That meaning 10 is the class interval. So here I value will be the class interval. So with one problem we can explain this. Following table gives the distribution of salary of 100 households in a village. Calculate standard deviation. So salary in rupees 0 to 1000, 1000 to 2000, 2000 to 3000, 3000 to 4000, 4000 to 5000, 5000 to 6000. Number of households 18, 26, 30, 12, 10 and 4. Now solution we can see in the table. See, only difference is that D we are dividing with the class interval. That is the 1000 is the class interval here. So when you substitute the values in the equation, we will get 186 divided by 100 minus 18 divided by 100 squared, and you are taking the square root into 1000. So you will get rupees 1351.9. That is the value of standard deviation. Now we have to see the merits of standard deviation. It is the best measure of variation. Now computation is based on all values. Now it's not affected by sampling fluctuations, and it's also capable of further mathematical treatment. Combined standard deviation can also be computed. These are all the advantages. This is not possible for other measures of dispersion. So relative measure of standard deviation is the coefficient of variation, and it's used extensively in computing variability of two or more distributions, performance of two companies, performance of two batsmen, performance of two students. All this we can compare using coefficient of variation. So used in further statistical computations like skewness correlation. When we are calculating skewness or correlation, we are using standard deviation for computation. Now, the limitations of standard deviation. Standard deviation is difficult to compute. Different methods we have learned, and I advised you to use the simple method. Whichever you are finding it comfortable, you can use the method. But we can say that this is difficult to compute compared to other measures of dispersion. Now, this will not reduce the importance of standard deviation because it's widely used and it's accurate results we will get. So that is the information I want to explain with this module, that is standard deviation, and thank you.